This Week in Science and Education is presented in association with the Science Coordinators and Consultants Association of Ontario. Visit their website at sccao.ca.
This Week in Science and Education is brought to you in part by the University of Western Ontario, www.uwo.ca. We thank them for their support. This Week in Science and Education is also brought to you by Laurentian University. Check out Laurentian at laurentian.ca. We thank them for their support.
Hey everybody, it's time for This Week in Science and Education. This is your host, Kevin Cougler. This is T-WiSE, episode 82, recorded Thursday, May 24th, 2012. Climate change. Why are we still talking about it? Hey everybody, thanks for taking the time to join us today. Very excited to have with us Gordon McBean, who is a climate change expert here at the University of Western Ontario. So we're going to get to him shortly, but before we do, let me welcome in my regular co-host, Colin Jagoe from the Kawartha Pine Ridge District School Board. Although, Colin, you're not at Kawartha today.
I am not. I am currently located at the Upper Grand District School Board in Guelph. I'm here for a one-day conference and event, so I've snuck out of that for a half an hour, and I'm talking to you guys.
Now, did they know that you're sneaking out? If they watch this afterwards, you're going to get in trouble, or are you okay?
No, not at all. I got clearance from the boss to sneak out and do this, so we're good.
Excellent. Well, thanks for joining us and taking time out to do that. Speaking of a guy that takes a lot of time off, Dr. Thomas Merritt, Laurentian University. Hey, Thomas.
It's good to see everybody. Gordon, thank you very much for coming on. I appreciate it.
Mm-hmm.
Appreciate being here. Good timing topic.
So let's get to Gordon, actually. Gordon, thank you for taking the time to be on the show. As Thomas mentioned, very excited to talk to you today about climate change. I guess before we get into why are we still talking about it, maybe just give a little bit of background on yourself and your career path and what you're working on now.
Okay, well,
I'm sure that's more than 30 seconds, but...
well, very quickly. I mean, I'm a climate scientist who started off studying physics. I did my PhD in physics of the atmosphere and the ocean, and I think that's important because many of the fundamental questions that we talk about on climate science are due and relate back to principles of physics. Radiative transfer, motions in the atmosphere and the ocean, that kind of thing. And let's say I'm old enough to know that despite what certain people always say is that, back in the 70s, these climate guys were talking about the Ice Age. Well, I was a climate scientist in the 70s, and I have no recollection of ever talking about the Ice Age is about to hit us.
Right.
So this is an issue which has been, in the scientific community for a long time. And anyway, as I said, I'm a climate scientist. I started off actually studying the microphysics of the atmosphere, and then worked my way up to bigger and bigger things. And then by the 80s, I was a full-fledged climate scientist by looking at the way in which the ocean, in the North Pacific Ocean in this case, transport heat from the equatorial regions to the polar regions. And the oceans play a fundamental and huge role in the climate system. So I studied that. I worked at the Institute of Ocean Sciences and then went to the University of British Columbia as a professor and eventually head of the Department of Oceanography. And then I got asked to become an assistant deputy minister in Environment Canada. So you get your mind kind of warped when you do this. You soon discover that those sessions you spent with the grade 5-6 classes on the floor, as I did as UBC professor, explaining climate science to a 10 or 12-year-old was just exactly the level of understanding you needed when you talked to certain ministers. Not all, just some.
Do you want to name them? Or?
Okay. I'm still friends with some of them. So I spent 6 years, and I learned the process in which climate change becomes a societal issue by, let's say, hands-on involvement. I was in Kyoto when the Kyoto Protocol was written. But by 2000 came around, I decided I'd had enough of that kind of life, and I'm now a professor since then at Western. I actually appointed a professor of geography and political science. And but not entirely. I do a mix of policy, natural science kind of things on climate change, but focusing mainly on the impacts of climate-related events on people, ecosystems, how they are now and how they'll be in the future. So that's what I am.
Go ahead, Thomas.
So one of the things I thought we might really start a conversation with is just try to talk about the difference between global warming and climate change and maybe why that vocabulary is both informative and can sometimes get in the way of the conversation. So we're talking about climate change. A lot of people say global warming. Are those the same thing? Are they different ways of saying the same thing?
Well, I think climate change is a broader term. Global warming just means it's getting warmer, and it is indisputably getting warmer. But seeing the things that, quite frankly, really affect us more directly is the increasing frequency of heavy precipitation events leading to flash floods. We're seeing, in a statistical sense, the more likelihood of a very hot day. It's not just warming, but these extremums, these 30-degree Celsius days. We're seeing the impacts on typhoons, cyclones, hurricanes, Colin. I was recently in Taiwan, and I was actually there in 2009 when Typhoon Morakot hit the island. 2+ meters of rain fell in less than 24 hours. A mudslide, basically a whole village of 700 people disappeared as the mud went down. And on my visit a few weeks ago, I was taken, I was speaking at a conference, but then we went on a tour through where they're reconstructing villages for the survivors of this terrible event. And so we get into these societal issues in climate change quite quickly because it relates to, and even if the climate wasn't changing, we're still having these, but the evidence is that the likelihood of a typhoon being more ferocious, heavy winds, heavy rain, is higher now than it used to be, and it will get worse.
So how do we actually? Sorry, how do we actually determine that? So how do we know that the storms are worse, the incidence of storms are worse now than they used to be? What kind of evidence do we have to compare? I mean, so it's easy to record things now. What are we comparing that to?
Well, several things, but first of all, we have not fully globally coverage, but nonetheless, we have an observing network set up by weather organizations going back into the middle 1800s. So we've got 100+ years of observation, temperature, and precipitation at many, but not locations around the globe. For the satellites have been measuring the characteristics of typhoons, hurricanes since the 70s. Certainly into the 80s we have measurements. So it's a mixed bag, but that's where your scientific insights, the way in which you get the best scientists looking at it, and you can come up with answers which, under scrutiny, by looking at and comparing and, quite frankly, a bit of shouting back and forth, say, yeah, we agree, that's the way it is, with this level of uncertainty.
Do you have any footage of that shouting back and forth? We could overlay it as on the podcast here.
Yeah, I'm sure I could find some somewhere.
Before we started the show, we were talking with Colin, and he made the point that, Colin, are you still there? Your video's a little frozen.
I'm still here, absolutely.
Okay, good stuff, because it's a great image of you grinning ear to ear.
Okay, good, awesome.
Colin, you're making the point that why are we still talking about this? It's still it's part of the curriculum, climate change. Talk a little bit about that.
Yeah, well, it is, and I mean, it's thing that we present climate change, we present the evidence for climate change. In some cases, we present the evidence against it to look at all of the data and to get kids to think critically. But the question that's sort of occurring to me, and Gordon, maybe you can talk a little bit about this, is why are so many people invested in the belief that it's not happening? Why are there the vehemence of sort of the counter argument there? Because I think about it critically and I go, I don't really have any personal stake whether it is or isn't happening. I look at the evidence, I take the scientist's word, and I understand the process, and I go, okay, they say it's happening, I get that it's happening. Can you maybe speak about societally and why there's so much opposition to it in the face of so much evidence?
Yeah, well, let me say, first of all, that if you were to do a sampling of all of the real climate scientists in the world, you would find 80+% would say they agree with the conclusions of the Intergovernmental Panel on Climate Change, those kind of assessments, climate change, those things we're talking about. There's probably 5% of bona fide scientists who say, no, not really, because of they don't believe the data is quite justifiable or something. And there's probably another 5% equally or perhaps even better climate scientists who say that the Intergovernmental Panel on Climate Change has been too conservative. It's going to be even worse than that.
Right.
So there will always be that extremum. But you got to remember there's several issues involved here. And the most fundamental thing is that if you take action on climate change, as we largely talked about it, that means reducing the consumption of fossil fuels. The fossil fuel is very, very expensive, very well funded, and let's say certainly provides, I'm told, resources. I personally don't know for sure, but there's books like The Merchant of Doubt, which actually chronicles, this is an American book, how the same scientists who worked through in the 70s were the people standing up saying tobacco has no effect whatsoever on your health. Later 70s, when I was standing up saying about acid rain, the same guys apparently, I didn't recognize them as the same, were standing up saying acid rain is nonsense. And those same people are now into the climate change business and have been, and certain very conservative think tanks provide them the funding. So the other thing is a lot of people choose not to believe things because it's inconvenient to them. It means they have to do something they naturally want to do.
And there might be a price tag attached to that as well.
Yeah, and the other trouble is that climate change is a decadal and longer issue. It's not, I mean, I actually briefed the Canadian federal cabinet of the previous government, which actually up to Ottawa to brief them. And one of the ministers said, "You mean to tell me, Dr. McBean, you want us to do this, this, and this, and nothing will happen between now and the next election?" And I said, "Yes." And I said, "Because you do it for your children and grandchildren." Absolutely. This is a children-grandchildren issue, and it's a children all around the world issue. It's a global society issue. And quite frankly, unfortunately, many people are selfish for their own objectives, ambitions in the very short term, near sight, and this kind of seems to muddle the water a bit, and they don't want to do it.
I think that's probably a good spot to take a quick break. We're going to thank our sponsors and be right back with Dr. Gordon McBean from the University of Western Ontario.
This Week in Science and Education is brought to you by Sheridan Institute of Technology and Advanced Learning. At Sheridan, students shine brighter. Check out sheridanc.on.ca.
And we're back. Thanks, everybody, for sticking with us. Our special guest today is Dr. Gordon McBean from Western University. Colin, before we broke, we were talking a little bit about them and the issues arising, what you're teaching the kids these days.
Yeah.
I think you had another point to make on that, so let's go back to you.
Well, actually, I had a question because you mentioned, the practice you had teaching younger students about climate change and how it, benefited you when you were in Ottawa. Climate change is a complex issue, and whenever you delve into it, you realize, there's many, many factors that affect the climate. And you mentioned the ocean, and we got the atmospheres and land and the greenhouse gases themselves. All these different things play a role. Is there ways of approaching teaching climate change that would be really beneficial to help kids understand it, to think critically about it, to analyze evidence, to look at it maybe in small chunks that are understandable? What are some of the approaches we can use in classrooms to help, to help teachers, to help kids understand this?
Well, I try and explain the issues of, for example, what I was trying to do when I was speaking to Catholic Central High School last week was explain the issue of the fact that there are certain laws of physics that basically say that things radiate depending on their temperature. And so I point out the ceiling light and I say, I know that light must be 5,000 or 6,000 degrees Celsius because otherwise I wouldn't see it.
Right.
Because it's got to be that hot to emit that kind of radiation. And then we got into the question is why is the sky blue? And I went around the class, 5 or 6 of them had different ideas, but none of them were wrong. So we try and build, at least what I was trying to do was build on this understanding of principles of science. And so when people like the skeptics might say on the climate change issue, as they've said, the greenhouse, CO2 is a trivial gas. Well, we can show by looking at analysis of what's happening on our own planet, if that is the case, then why are we the temperature we are? We're plus 15 degrees Celsius. Out from outer space, we look to be minus 18. The difference, that greenhouse effect, 33 degrees Celsius warming is non-trivial. And in fact, none of us there would be no civilization, no evolution on this planet if we didn't have a natural greenhouse effect. And so I was trying to relate these things to things people can connect to. And maybe I don't know whether I succeeded, but at least I was getting a sense of positive feedback.
Good. Okay.
Is there anything that students can do, in the class or at home, where say they wanted to measure, I don't know, effects of climate change, or kind of dive into a hands-on activity? What can they do as, say, a 10-year-old or a 14-year-old, to kind of grab some proof of this? It's hard because it's over time, right?
It's very hard because first of all, you have to look over a decade or more time. You also need to look at spatial patterns. I mean, I can find places on the planet that are cooling. But nonetheless, globally, it's warming.
Yeah.
You might want to look into some of the sort of impacts of climate change. Why does it matter? And then you can start saying, I usually start when I'm with the littlest kids. Most kids have been with their parents to Disneyland or Disney World. And I say, well, okay, you got in the car and you drove from Ontario or British Columbia, where I used to be, down to California or Florida. And what did you notice about the trees? They vary. Some certain species, and you get down there, they're tropical trees. But why is that? That's due to the climate. And so climate relationships. So if you start changing the climate, what does it do to those things? So you could perhaps do experiments in a simple way, high school classroom, where you actually just move the climate in a little chamber and see what happens.
Yeah.
That you just gave all of the kids of Canada a reason to get their parents to take them to Disney World or Disneyland.
Right.
Beautiful.
My grandkids are working on. I've taken them once by airplane.
Little demonstration. No, that's okay. There's one interesting demonstration I saw one time is you take two glass aquariums, and you take some carbon dioxide gas, either from a tank or from soda pop or whatever, because carbon dioxide sinks. It's more dense than air. So you put some carbon dioxide in one aquarium, put a cap on it, and then you leave the other one just regular air, put a cap on it, and then put thermometers in it. And the one with the carbon dioxide in it, and you monitor the temperature in the sun, actually will start to warm up faster as a result of having carbon dioxide just added to that aquarium. So there is some little activities that I know people can play with just to sort of test some of those kind of things. Carbon dioxide makes it warm faster, just as one example.
Perfect. Those are fantastic ideas for those teachers out there. Teachers, I hope you're listening. We got some good stuff for you here today.
Well, an interesting, very simple science question you can ask, and one of our leading scientists in the country slipped up on this one when, without thinking about it, I asked him in front of a large audience, when the ice off Antarctica slides into the ocean as a glacier into the ocean,
right,
how soon does the sea level rise? And he said, well, when it melts. And I said, really?
No. The second it hits the water.
I used to do with the kids when at UBC, they had a scientist in the schools program, which I volunteered to. Anyway, and we would go out and you'd put a glass of water with a blotting paper underneath it, full it, enough ice in it and water so it was right at the brim, and just note to the kids. And then at the end of the talk, you could look and say, now it's all melted. All that ice is melted, but none of it is spilled over. The sea level doesn't change when you melt the Arctic sea ice.
The Arctic sea ice.
Ecosystem, the climate, but it doesn't. That's not, as often people say, the cause of sea level rise.
I think we better go to Thomas. I'm quite concerned. He's uncharacteristically quiet, and I want to make sure he's still awake. Okay, Thomas, are you there?
Yeah, this is what happens when you get a geneticist to talk about climate change. I actually,
well, we can go back to Colin if you want.
I have a question going back a couple of points. Gordon, one of your focuses is on instability in storms and catastrophes. Why is climate change associated with an increase in catastrophic storms? What's the connection between those? I mean, we can see it, but what's driving that?
Well, the fundamental principle is that the amount of water vapor that the atmosphere can hold depends on its temperature. So if you warm up the temperature, it can hold more water vapor. And so and most of the energy for storms actually comes from the phase change of water vapor to water as a liquid. the gas, gives off that energy going from the gas phase to the liquid phase. If you have more of it because it's warmer, then you get more energy. And so a warm, moisture atmosphere is naturally more energetic than let's say, a cooler, drier one. That's why we don't get the kind of deluges in our latitudes that you do in, California, well, say Florida. And as you go up to Iqaluit, it's very different again.
That's awesome. Yeah, I had no idea. That's great.
Yeah.
Gentlemen, I'd just like to read out some of Dr. McBean's qualifications here. He really is quite an impressive individual. I hope I don't embarrass you by doing this on the air, but I want the listeners to understand the level of your expertise that you're bringing to the show today. So I'll just read this verbatim. Dr. McBean is a recipient of the Order of Canada, as well as the Order of Ontario. He's a Fellow of the Royal Society of Canada. Now, are you currently the chair of the Canadian Foundation for Climate and Atmospheric Sciences, or is that past post? That's your current position, okay. Formerly the ADM, as you mentioned, Environment Canada, and was also one of the recipients of the Nobel Peace Prize awarded to the Intergovernmental Panel on Climate Change back in 2007. So I'm afraid we're fairly close to being out of time, but I wanted the listeners to be aware of the level of your expertise.
Absolutely.
Who would like last crack at Dr. McBean? Last question of the day. First guy to wink at me wins. Neither one is winking. Let's make it easy. Thomas.
Thank you. I guess the issue that you were talking about earlier, that a lot of what's driving this is not our concern for ourselves, but our concerns for our children and our grandchildren. How do we get that point across to kids that are school age? I'm only now beginning to appreciate that I might actually have grandkids. How do we sell the 8, 10, 17-year-olds on this sort of long-term planning?
Well, I think we can sell it in terms of the climate issue, but we can also sell because the whole environmental system is highly interconnected. The same use of fossil fuels that creates the greenhouse gases is largely creating the smog. And we're seeing the impact of smog on our health, the smog, etc. So we can make these connections between the environmental issues. It's not 1, 2, 3. They're all in a comprehensive way. So I think that kind of thing can help. And I think the other reality is, we're having storms right now. I'll be speaking to the Empire Club, to a huge bunch of business guys a couple of weeks from now, 130 of them apparently. And they're there because the insurance companies are now saying the biggest cost to them, their insurance, which used to be for the homeowner's policy was fire or theft, is now rain-induced damage. They paid out over $1 billion a year the last few years. And that means you're paying it. Your dad and mom, for the kids, or me in my case, you guys, we're paying it because all of our premiums have to be such that it compensates for the cost of these things. And billion-dollar events, I mean, there are dozens of them around the world now, every year.
All right. Yeah, that's great. Thank you.
I think we're going to call it a day. We've gone a little bit over time, but I think we'll all agree it was time well spent. And Gordon, thank you so much for your time today. Really appreciate it.
Enjoyed it.
On behalf of Dr. Colin and Colin Jagoe from the Kawartha Pinehurst District School Board, this is Kevin Cougler from Virtual Researcher On Call saying thanks everybody for tuning into This Week in Science and Education. We'll see you all again same time next week. Have a good week, everybody.
See you, everybody.